Okay, so let's go over these problems that you had for homework. Number 1, helicopter speed increases from 10 to 60 in 5 seconds. What's the acceleration? So this is a simple problem using our formula. So 60 minus 10 divided by 5 gives us 10 meters per second squared. Number 2, while traveling along a highway, a driver slows down. So we have that keyword from 24 to 15 in 12 seconds. So we know that this is going to be deceleration. So I'm going to skip the formula part and just put 15 minus 24 divided by 12 is negative 9 over 12, which is negative 0.75 meters per second squared. So if we continue, number 3, after traveling for 6 seconds, a runner reaches a speed of 10. What is the runner's acceleration? Here we can assume that the initial velocity is 0. So 10 divided by 6, which should give you 1.6 repeating, and we could just round it off to 1.67 meters per second squared. As we continue, again, we have another example of deceleration. So we can say that 6 minus 25 divided by 0.5 hours is negative 19 over 0.5, which gives us 38 miles per hour squared. So again, in this case, just to remind you, we have final velocity minus initial velocity. So we have 6 minus 25 because the cyclist slows down from 25, which is the initial velocity, to 6, which is the final velocity. Let's continue. A parachute on a racing dragster opens and changes the speed of the car from 85 to 45 in 4.5 seconds. What is the acceleration? So again, 45 minus 85 divided by 4.5 seconds gives us 40 over 4.5. Excuse me, that's negative 40 over 4.5, and that gives us negative 8.89. I'm going to round it off, meters per second squared. So if we move on to the next one, you'll notice that the numbering on your questions are a little off. I apologize about that, but just follow along based on the word problem. So this one's a little bit different since we're actually given the acceleration. So a cart rolling down an incline for 5 seconds has an acceleration of 4. So here we're given the acceleration. If the cart has a beginning speed of 2, what is the final speed? So what we're doing now is we're looking for final speed. So one of the ways you can do this is just using your equation. You basically just plug in the numbers or values that you do have. So we do have the acceleration, so I'm going to fit it in, that's 4. I do not have the final velocity, that's something I'm looking at, the final speed, so I'm going to use x. I have the beginning speed, which is 2. I have the time, which is 5. So now I'm just going to solve for x. So we're going to do 20. 4 times 5, 20 is equal to x minus 2, and x is equal to 22 meters per second. Now, if you think about it, and you want to think through this, it actually makes a lot of sense. If I'm accelerating at 4 meters per second squared, that means that every second my speed changes by 4. And if I'm doing this for 5 seconds, then I'll just do 5 times 4, which will give me my final speed. But I started at 2, so I need to add 2, which gives me the 22 meters per second, which is the final speed. So, but for those of you, again, who like to use formulas, you can just use your formula, plug in the numbers that you have, and then solve for x. So let's continue. Number 7, a motorcycle is traveling at 25 meters per second, and it accelerates at a rate of 7 meters per second squared for 6 seconds. What's the final speed of the motorcycle? Very similar to the previous example. So we're going to do our acceleration of 7. So 7 is equal to x minus 25 over 6. So we have 42 is equal to x minus 25, and x is equal to 67 meters per second. 2 more examples. Number 8, a car starting from rest accelerates at a rate of 8. What's the final speed at 4 seconds? Very similar problem. So here we have 8 is equal to x minus 0. And I use 0 because our problem states that it's at rest, divided by 4. So 32 is equal to x. So x is equal to 32 meters per second. Number 9. A cyclist accelerates at a rate of 7 meters per second squared. How long does it take the cyclist to reach a speed of 18? Now we're looking for time. So same thing, we use our formula, divided by time. We plug in the values that we have. We have acceleration, it's 7, sorry. Our final speed is 18. Our beginning speed is 0. We can assume that it's 0. And x is our time, which we have to solve for. So 7x is equal to 18, and x is equal to 18 over 7, which is I'm going to round it up to 2.6, and that's seconds. So that's our answer. And that's about it.